Okay, so to continue with what we were working on before, so this is an expansion question. And hold on a second. Where did my... Okay, there it is. And we're going to split this up into, because we see division, so we're going to take log base 11 of 11 minus log base 11 of y. What is going on here? I don't understand why this is not staying where I want it to stay. So now, when I do this, okay, sorry, I was dealing with a technical glitch, but I figured it out. So, is that part that I circled in red something that can be simplified? Can we either rewrite it into its exponential form, something to the something power equals something else? Can we do that? And if so, you know, because I remember I told you set it equal to x, and we can do that changing. The base is 11, the exponent is x, and it equals 11, right? Or we could do log 11 over the log of the argument over log of the old base. We could use a change of base theorem. But it doesn't matter. You're still going to get 1 for that first part. So the most simplified answer for this is 1 minus log base 11 of y. That is the most simplified version because the first part can be simplified. And I would expect you to do that. Now, question 21. This is a base 10. Now these questions are saying things like log without using a calculator. So without using a calculator, we would have to change to exponential form to kind of look at it. Since I see division, what operation am I going to put in between there? I am really hoping that you said subtraction, because you would be right, because division changes to subtraction when you expand. Is this something we can simplify? Remember how I said set it equal to x and change it? Something to the something power equals something, in this case a lot of somethings. So the base, what's the base? Right here it is. It is a 10, right? When it's not there, we know it's a 10. The exponent, well, that's on the other side because we know a single word synonym for logarithm is exponent. And that leaves me the 1 billion number in here, which is the same thing as 10 to the 9th power. 9 zeros, right? So we know the answer to this question, right? The answer is going to be log y minus 9, because that part right there ended up being a 9. Okay, 22. We're just practicing this just to kind of, I know it seems like we're overkilling it, but this is not the easiest thing for you guys in the whole wide world. So this is a base 5 logarithm that we're expanding. The numerator goes in the first one. The denominator goes in the second one. And because it's division, we subtract. Okay? Now, can you simplify this piece right here? Remember I said set it equal to x, something to the something power equals something. The base obviously is a 5, right? The exponent, well, we know that's x, and what it equals? 25. Which that's 5 squared. So that must mean that we're dealing with this thing in the parentheses is your 2. And then, of course, the other part, minus log base 5 of y. So one part simplified, the other part did not. Now there is one last logarithm property that was actually made famous in a movie. And that movie would be Madagascar. King Julian. See if I can bring up a picture of King Julian. Some of you might remember King Julian, right, from Madagascar. Anyway, he made this particular, he sang a song that was talking about this next property. And the property says that if you take the exponent, you are allowed to move it to the front and rewrite this as 3 log base a of x. Now, the song that he sang was, you like to move it, move it. We like to move it, move it. Move it! You know. Dun, da, 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 da. Anyway, so, yeah, the move it property is, he's talking about coefficients and exponents. So, suppose we are changing to a single logarithm. So, this would be Beyonce, right? Single log. Because what she is suggesting for this problem is that we take this and move it up and make it an exponent. Whereas the expanded version, so I guess a single log, so single log has a coefficient, that's the number in front. Is it 2 F's or 1? I don't know. I'm going to have to check. Coefficient, I hate double consonants. Coefficient equals 1. That would be the number in front. Whereas an expanded log, so going this direction, that means the argument has an exponent equal to 1. So in this particular situation, number 23, they're asking me to expand. So my answer is 3 log base a of x. Now, a few seconds ago I wrote down that the argument has to have an exponent which is equal to 1. And look, there it is in the blue that I just wrote down. By moving that exponent, that 3, down and making it a coefficient, I have now reduced that exponent to just plain old 1. Now, when I say I've reduced it to 1, don't sit there and go, well, are you subtracting? No. Remember, every exponent, you know, if I were to rewrite this number 3, it's really 3 times 1. So by moving the 3 down in front. So this one's pretty easy, right? The negative 4 comes down in front. Negative 4 log n. And that's all you have to do for that question. We're just expanding. Use properties of logarithms to condense. Okay, so now they're right. This is like another way to say, you know, what Beyonce was saying when she was talking about all the single logs. So I see subtraction and I want to change this into a single logarithm. Well, what am I going to do? Well, it's the log of a fraction. What fraction is that? Well, the first part is the numerator, 2x plus 1. And the second part is the denominator, x. And no, I can't do anything more with that because I don't know anything about the x's. That is as good as it gets. Okay, use properties of logs to find the exact value of the expression. Do not use a calculator. Okay, so I've got, all right, 12 and 2. Oh, and it's got subtraction, so that would be log base 6 of 12 over 2. If only I knew what 12 over 2 was. That would be log base 6 of 6, and when we set that equal to some unknown value, hopefully you're getting the hang of this, and you can say, all right, the base is 6, the exponent we don't know, and what it equals is 6. Now that happens to be 6 to the first, so ding, 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 we got our answer right there, right? That exponent and that exponent have to be the same. So the answer to this question was a big fat 1. With a PH, right? Because it's really cool. Question 27. Try some of these on your own. Now, I will tell you before you try this, the first thing you'd have to do is move that 5 up. Okay, that's why I wanted to start doing some examples where we're mixing the properties together. All right, so log base 2 of 128 equals, oh, not equals, what am I doing? Minus log base 2 of 2 to the 5th. Now 2 to the 5th, what is that? That's really the same thing as 32. So now I can put these two things together, right? Because I see subtraction there, that would be log base 2 of 128. So the numerator is 128, the denominator is 32. Okay, that's the same thing as, let's see, 32 goes into 128 4 times. Right, because 3 goes into 12 4 times, and 2 goes into 8 4 times. Okay, makes sense. Well, set it up as, set it equal to something. Something to the times something to the something power. The base is 2. We don't know the exponent, that's x, and what it equals is 4. So the only exponent that could make that happen is 2, right? 2 squared is equal to 4. Okay, now we're expanding. Okay, this says expand. So first we log base b of z to the 4th, and log base b of x. But what goes in between? Well, because that's a product, this would be addition. That would be step number 1. So if you want to try to figure out what the second step is, before I do it, pause and try it on your own. Okay, there's only one thing left to deal with. We know that every one of those exponents has to be a 1. This one's already a 1, so that's good news. But that 4 is not, so using the King-Julian property, we move it, because we like to. So, for log base b of z plus log base b of x I think I sung the King Julian song earlier, isn't it? I like to move it. Yeah, that sounds better. Yeah, I screwed that up. I know later in the song, like, we like to move it, you like to move it. You're right, but I screwed up the first part. Yep. Okay, so write it as single log. So, all the single logs. All the single logs. That's a horrible 5. I need to erase it. Alright, so move the 5 up, make it a 2. And now I'm staring at this addition, and I've got to deal with 2 to the 5th and 7. What am I going to do with them? I'm going to put them together and make a single logarithm, so that would be log, what is 2 to the 5th? Isn't that 32? Yeah, and 32 times 7, well, that's like 210 plus 14. What's 210 plus 14? Isn't that 224? I do not think that is something I can simplify, because not unless I use a calculator, because this is base 10, so I could use a calculator, right? I come over here and go log 224, and it's got to be more than 2, right? Yep, 2.35 approximately. All they wanted is a single log, so we're just going to stop with that. Log 224. I don't need to change this stuff to nasty decimals. Who needs that? Use properties of logarithms to expand. Okay, so log base b of x squared over y over z to the 8th. Okay, so lots of stuff going on here, but I know I can put everything on the top, so that'd be log base b of x squared y minus log base b of z to the 8th. Okay, so we split apart the quotient. Now it's time to look inside. Like, remember I told you that exponents on the arguments had to be 1s? Well, that's obviously not a 1, so I will be using the move it property and bring that down in front. But right there I see a product, and I need to split that apart too. So one thing at a time here. So we got log base b of x squared. And then because that's a product, I'm splitting it apart into addition. Log base b of y. And then minus. And if I bring that 8 down, that would be 8. But it looks like I've got one more exponent to deal with, because I got an exponent of 1 there and a 1 there, but I don't have a 1 there, so I need to bring that down. So 2 log base b of x plus log base b of y minus 8 log base b of z. A lot of work to show there, folks. Make sure you're showing the work as you go through that. Quite a few steps there. Okay, on 31 here, now we're going the opposite direction. We're writing it as a single log. So, first thing I want to do is move the 7. So now I have log y plus log z to the 7th. And we got to do something with those two things, because we see addition. We're going to multiply those together into a single logarithm, so log yz to the 7th. And that's really it right there. So we moved the 7, made it an exponent, and then multiplied the arguments together to make a single logarithm. 32, also single logarithm, so we would move those up. Make that log base b of x to the 5th plus log base b of z squared. Now what? I see addition right here, so that must mean I'm going to do something with the x to the 5th and the z squared. Put them together into a single logarithm. Log base b of x to the 5th z squared. And that is our final answer. Now hopefully, well, I'm going to make sure I open up the Math Excels for these, so you guys can go in and practice some of these and feel more comfortable with them, especially since I'm not there to help. But you have a good sub who can help you as well.